In this video, I will talk about least square estimation and Python implementation for an engineering problem. There are many forms of least square estimation. I will talk you through the estimation of constant in this video, which is like if you have a measurement of a constant and you want to find what is the best value for that number. You can also heard about linear coefficient, which is try to find the best coefficient for a linear problem. To get back to the same estimation of constant, so you are trying to measure a resistor with the help of multimeter, and the multimeter has a known error built into it, and you have done 100 measurement and you want to find what is the best value for this resistor. So once you have done the measurement, what would you do is you take an average of all the values, and probably that works okay. How can we prove the same thing with the least square estimation? I will go back to the quotation given by Carl Friedrich Gauss, where he mentioned that if you find the error, which is the measurement minus estimate squared, and then if you add all those elements, that gives you the cost function. If you minimize this cost function, that would be the best value for that estimation. Let's come back to the problem. You have a y, which is the measurement vector, and x is a constant we don't know, in this case our resistance value, and v is coming from the multimeter measurement error itself. And you can create an error matrix, which is the measurement minus h into x matrix. In this case, it's a constant. Let's take a look at the cost function again. We can rewrite that information into a matrix format using this formula, which is error matrix transpose and multiplied by error matrix. Substitute with the equation that I explained earlier, you get this form, and we can expand that into this form. And our idea is to minimize this cost function. To minimize the error, you simply take a partial derivative with respect to x and set it to 0. When you do that, the equation becomes simplified, and you set that partial derivative to 0, you would have x hat, or the best estimate is in this form. And we need to find out what is H matrix and Y matrix, and that's it. We can able to find out the best value for X on this constant. Let's look back our problem of resistance. So you have a measurement, and that measurement has a constant value with the error coming from the multimeter, and the same applies to the n number of measurement. Let's convert that into a matrix format. So you have a measurement matrix, and H matrix is 1 because we don't have any variation in it. We just X is constant in our case, and we have the error matrix. Then X hat, we want to substitute this H matrix and Y matrix into this formula to find out what is the X hat. Let's do it on the next slide. Okay, so I can see here I have substituted the matrix here, and to do this matrix multiplication, you would multiply the first element of this H matrix into this matrix, and then you add it to the next element. When you do that, you simply add all the element of this value that gives you 100, and you do the same thing between this H matrix and Y matrix, and that gives you sum of all the Y matrix. So you would end up sum of all the Y divided by 100, which is the number of measurement, that is the average of Y. Let's implement this in Python. So I have done a measurement generator, which is basically, since I don't have the resistor multimeter to generate the measurement, I have used np.random.normal function to create a measurement generator. I have taken a mean of 0 and standard deviation of 2 and measurement number to 100. I pass to this function. That gives me the measurement array using this formula. Then I pass that measurement into a x hat calculation and also how many measurements I have taken into this function. In this function, I have created H matrix using np.ones, and the Y matrix is simply the measurement array. And then I used a matrix multiplication to calculate H transpose H, and then the same matrix multiplication to calculate H dot Y matrix. Then I have calculated this X hat, the best estimate using this formula. Let's run this formula and see like whether it's same as the least square estimation and the average value. As you can see that you have X hat least square average. Least square method gives me 39.9 and average method gives me exactly the same number. I hope this explanation of how we have end up having the least square estimation formula helpful to you. Thank you.